Processing Lab. Experiment number 02, Difference Equation, System Identification. Convolution and Deconvolution. Difference Equation, System Identification. 1. Convolution and Deconvolution Objective. This lab focuses on the creation of discrete time signals in Matlab and explains the required Matlab commands. After performing the lab, the students will be able to create discrete time signals in Matlab, use Matlab commands to perform simple operations on discrete time signals. 2. Resources required. A computer, Matlab 7.0 or higher. 3. Difference equation. The difference equation is a formula for computing an output sample at time based on past and present input samples and past output samples in the time domain. We may write the general, causal, LTI difference equation as follows: Piam poa equals poal 0 piolg poa plus poal 1 piolg poa minus 1 plus poal per yolg poa minus poal 1 piam poa minus 1 minus poal poig piam poa minus poag poag. Piam poa equals poal poa piolg poa minus doa minus poal poach piam poa minus toch. Poa equals 0, poach equals 1. 4. FIR System Identification. Estimating an impulse response from input-output measurements is called system identification. Cross-correlation can be used to compute the impulse response Hn of a filter from the cross-correlation of its input and output signals Xn and Yn equals Xn asterisk Hn, respectively. To see this, note that, by the correlation theorem, piolg piam if and only if poelb pearls equals poelb poek poelb equals poek poelb 2. Therefore, the frequency response equals the input-output cross-spectrum divided by the input power spectrum. Poek equals poelb pearls equals poinch piolg piam poelb 2 poinch piolg piolg. Where multiplication and division of spectra are defined point-wise, i.e. poek piolpuk equals poelb piolpuk pearls piolpuk poelb piolpuk 2. %Matlab code % correlation to compute the impulse response of a filter given its input and output. This is called FIR system identification. Close all, clear all, CLC, NX equals 32%, input signal length NH equals 10%, filter length NY equals NX plus NH minus 1%, max output signal length %FFT size to accommodate cross-correlation, NFFT equals 2 next power 2, NY, %FFT once power of 2x equals rand 1. NX% input signal equals noise %x equals 1, NX% input signal equals ramp h equals 1, NH% the filter XZP equals x, zeros, 1, NFFT NX% 0 padded input YZP equals filter H1. XZP % apply the filter X equals FFD, XZP % input spectrum Y equals FFD, YZP % output spectrum RXX equals conj X asterisk X % energy spectrum of XRXY equals conj X asterisk Y % cross energy spectrum HXY equals RXY. RXX % should be the for Q. Response HXY equals IFFD, HXY % should be the imp. Response HXY 1 NH% print estimated impulse response for QZ HXY 1 NFFD% plot estimated for Q response R equals norm HXY H zeros 1 NFFT NH norm H disp sprint F impulse response error equals %0.14 F% 100 asterisk R equals norm HXY FFD H zeros 1 NFFT NH norm H disp sprint F frequency response error equals percent 0.14 F percent 100 asterisk her. 5. Convolution in Matlab without using built-in command. Output of LTI system Y n can be computed by convolving the input signal X n with system response H n. One method to implement is a fast convolution method which includes FFT of signal and system response. For much longer convolutions, the savings become enormous compared with direct convolution. This happens because direct convolution requires on the order of POG2 operations, multiplications and additions, while FFT-based convolution requires on the order of POG, POITH, PIOPOIS, POG operations, where POIT, PIOPOIS, POG denotes the logarithm base 2 of POG. Close all, clear all, CLC, n equals 1024%, FFT much faster at this length, T equals 0, n1%, 0, 1, 2, n1, H equals EXP, T, percent filter impulse response H equals FFT, H, percent filter frequency response X equals 1, n percent input equals DC, any signal will do, nrep equals 100% number of trials to average T0 O equals clock, percent latch the current time for I equals 1, renrep, Y equals CONV, X, H, and percent direct convolution T1 equals E time, clock T0, asterisk 1000%, elapsed time in MSEC T0 equals clock, for I equals 1, renrep, Y equals IFFD, FFD, X, asterisk H, and percent FFT convolution. T2 equals E time, clock T0, asterisk 1000, disp, sprint F. Average direct convolution time equals percent 0.2 FMSEC, and average FFT convolution time equals percent 0.2 FMSEC, and ratio equals percent 0.2 F direct, FFD. T1, renrep, T2, renrep,